Hi, this is Dr. Melissa Shotell, also known as the AligenerBee, and I'm at LMT Lab Day in Chicago, and I've made my way to the Voxel booth to check out a new and innovative piece of technology. So I'd like to welcome my special guest, Ben from Mayku, and we're going to learn a little bit about the new advancements that we're seeing in thermoforming. So Ben, can you tell us a little bit about yourself and Mayku?
Sure. Thanks, Melissa, and hello, everyone. My name's Ben. I'm from London, and I run a company called Mayku. And this is the Mayku Multiplier. It's a large format thermoformer. And so basically what it means is that you can do up to 30 appliances in a single pull down rather than doing one at a time.
Excellent. So if I'm hearing things correctly, we can thermoform 30 models at one time using your thermoforming machine. So can we see an example of this? Do you have one available? Excellent. So I'm noticing that this is a large size proprietary disc for the machine. Can you tell us a little bit about the large scale models or any individual discs that you can use?
Absolutely. So these are our EVA sheets, so soft materials. They're 4 to 8 millimeters in diameter, and they can fit up to about 30 models, depending on your model size, onto a single pull down. They're very easy to take out and then to put into our machine as well. But if you don't want to use our large format sheets, you can also... Would you mind holding this for me? Thank you very much. Let's swap this one out. You can also use the 7-shot reducing plate. Now, this will take 1 to 5 rounds, like these guys. Let's pull one of those one off. So these will fit on. This will do up to 7 in a single pull down of pretty much any thermoformable material that you may already be using.
So with this, I can essentially use your materials, or I can use any standard 125 millimeter disc that I would like to use. Excellent. So that is really an innovation in the multi-unit thermoforming space. So with most of the large-scale thermoforming machines that we're seeing only proprietary discs. So this gives us the ability to change between multiple materials. So with this, I would use the single discs.
Yep.
Otherwise, we would use the solid disc and pile on up to 30 models.
Exactly.
And any type of plastics.
That's it. Any type of plastics. It's a completely open system, so if it can be thermoformed, it will be thermoformed on the multiplier. We've also got a custom mode built into the machine. Now, what that means is that you can actually teach the machine a new material profile. So if we wanted to take Melissa's material profile, we could call it Melissa's material profile, set the exact temperature, the exact pressure, which is up to 5 bar, the exact forming time, the exact soak time. Every single bit of this machine can be modified and tuned to the exact lab tech that is using it. And then the machine will remember that for as long as you want it to.
Excellent. Well, this really is, something fantastic, both in the laboratory space and in the in-office space, so that we can see how to minimize our time that we're going to spend thermoforming. Let's go ahead and take a look and see how it's running.
Great. Okay, so this is going to be fun. What we're going to do is run through exactly how this machine works. So I'm just going to start off on the home screen. Everything you need to control this machine goes through this screen. So we're just going to press this to start. And there's a bunch of different types of material profiles already loaded onto the machine. We're going to pick EVA, which is this flexible material here. We're going to go for the 4 to 8 profile. Going to go down to 1.5 millimeters, and then we're going to go. This little screen here, you can actually adjust the tightness and the looseness of the fit, because we all know some dentists like to be picky about tightness and looseness. And so we're going to say yes. It's going to tell us to pop the material in. Going to make sure this is aligned. Bring the lid down, lock it off, and then bring it back up. Material has now mysteriously disappeared. And we can hear the compressor which is switched on. There is an internal compressor inside of this machine, so you don't need external air. That means that you can move it on a trolley anywhere in your lab and you can also change it or put external air in should you so wish. Our compressor is now charging up. Whilst that's happening, I'm going to run you through our auto leveling system. So something that no other machine has on the market is that when you actually heat a sheet material, what happens? Well, what happens is it starts to droop. Now, if it starts to droop, it gets thinner in the middle, and that means that you're going to get inconsistent appliances with thinner wall thicknesses in some areas and thicker wall thicknesses in other. What we'll see any second as this material starts to heat up is our material is going to stay completely level. How do we do that? We've got a little sensor in the base of the machine which is looking directly at the sheet material and checking how much it's going to be drooping at any given time. As soon as it starts to see it droop, it's actually going to switch that vacuum on and it's going to lift it up and keep it completely level, which means that you're going to get more consistent appliances and less returns. Now, the other thing that you can do is actually the opposite of that. If you just press this little up button here on the screen, it'll actually lift the material up instead of it drooping down. So the heaters have now come on, and that means that our material is going to start to be heated up. At this point, our compressor is going to switch off any second, but we can start chucking a bunch of different models onto the bed. Now, you don't have to be that sort of like specific about where these models go. There's just one golden rule, which is if your model is so tall, then keep the tallness of that model the same distance as it is away from the next one. So I'm just going to put myself down here, and we're going to start lining these bad boys up pretty roughly.
So we can put the models anywhere just as long as they're at least a thickness apart?
That's it. You can put the models anywhere as long as they're the height of the models apart. And we can
have the heating element here. We have a vacuum pulling up.
That's
and
it.
Then we have an air compressor down here to form our vacuum.
That's it. That's
Bravo.
it. That's it. And so what we're going to see any second is when this gets up to temperature, the machine will beep at us, and it will actually, therefore, we'll pull that whole thing down, and then we'll lock it off, and we'll drop about 5 Range Rovers worth of pressure into the top of this machine.
So how many pounds or how many bars of pressure is it?
5 bar. So that transfers to about 60 psi into the actual dome itself. And then you can also change the holding temperature or the holding time for that 5 bar to be kept in. So if you're using a soft material like an EVA, which is going to take a little bit longer to actually form, you can hold that in for as long as you really care for.
Because you really can't overcool the material, can you?
You can't overcool material. The longer you leave it to cool, the less deformation there's going to be. And it also means that we can be walking around and doing whatever we want whilst this is heating up. And you'll actually hear it in a second. It will beep at us. And at that point, we're going to bring this lid down. I'm going to hand you the mic. We'll lock it off. And then we'll see what's going on.
Excellent. Can I help you close it?
Of course you can. Yeah. You'll heat it. Right,
so we're almost up to temperature.
That's it.
So it looks like we're heating with this particular material to 130 Celsius.
That's it.
But we could heat this to any temperature we want for
up
any
to 250 degrees. That's it. It's beeped, so let's go.
Okay.
Down, cross.
Excellent. So we closed it down, locked it into place, and now we hear the cooling occurring. Excellent. So we have both the vacuum under the models and we have the thermo pressure above them.
So you've got pressure above the models, and you've also actually got vacuum above the models as well. The vacuum is what keeps that level material, right? So as your material starts to sag, you switch the vacuum on, and that's what keeps the whole thing level.
So we don't pre-stretch the material that way.
Exactly.
Okay.
And that means when you're actually forming over your appliances, you're forming over your appliances with a very consistent wall thickness. It's just not something that you would usually get with traditional vacuum formers or pressure formers. And we're in a holding pattern now, which means we've got about 20 seconds. We'll open this up after 20 seconds, and we'll have made however many appliances are on the bed.
Perfect. So the cooling cycle is over, and I hear the compressor already running. So that's getting ready for the next round.
That's it. So as soon as the cooling cycle starts, what we do is switch the compressor on, and that means by the time you've taken this off and you're starting to prep your models and take them out, it means that you're ready to go in your next cycle. So it's a very, very fast way of making your appliances, and as the machine heats up, the faster the cycles become. So if you're doing a lot, you can get very quick at doing this.
Excellent.
But yeah, we're good to go now.
Perfect. Let's open it up and see what we have.
Ready?
So there we are. We thermoformed over a dozen models all on one large scale sheet, or we could have done up to 7 models with our individual discs if we wanted to. Excellent.
Yeah, we've got how many there? About a dozen, but yeah, we could have fit more on there if we weren't filming. So yeah, you can get up to 30 depending on your model size, or up to 7 using the 7-shot reducing plate.
Excellent. Well, Ben, I'd like to thank you so much for joining me today and for sharing your new technology with us. It's always amazing when we can see some of the new innovations that we're having in the laboratory space and how we can refine and simplify our in-office workflows so that we can save time in our offices, being efficient, both in our in-office and in our laboratory space. So Ben, thank you so much for joining us today, and we're excited to see the new innovations from Mayku.
Thank you so much.
Thank
Absolute
you.
pleasure. Thank
Excellent.
you, AligenerBee.
Thank you.